Okay, so I think we were about to do the J48, right? Okay, so let's check that one. Okay, so it didn't do quite as well, but it did almost just about as well, right? How can I say that here? In the confusion matrix, you can check the diagonal entries. There's almost everything is in the diagonal. That means they were all correctly predicted. And then what about the two? They were wrong. And so what was the wrong? They were actually Virginica, but they were predicted as versicolor. Okay, and so both algorithms made the same kind of error, right? They both predicted Virginicas that were actually versicolor, right? And up here you can see the same thing. 49 out of the 51 were correct, right here. That's 96%. Okay, now this one is a little bit, there's a kind of a tree. They have visualizations. So let's try and look at this visualization, see about this tree. So with the tree one, you can sort of see a little bit more about how it's working. So what you do is you right-click on this this thing here. So I'm going to right-click, and it gives you a bunch of options. So you can see that one of them is called Visualize Tree, right? So let's look at that. Okay, so you get this picture. Okay, so you can also right-click on the picture and get, say, fit to screen. So I'm going to do that. No, how do you do that? Maybe you make it bigger here. No? How do I do that? Yeah, I tried to do that, but I couldn't do it. I tried dragging. Oops, what happened? Yeah, but, oh, okay, now I can do it. I tried it before, it didn't work. Okay, fit to screen. So there it is, right? Okay, let's see what how do I read this thing? So what's at the top? Petal width. And what are at the bottom, would you say? Yeah, what do you see at the bottom? Versicolor, Virginica, and versicolor again, right? Okay, does everyone see that? Those are kind of at the bottom, right? So the bottom has represents which variable of the 5 variables that we had. The bottom represents which one? The class, right? The bottom one represents the class. Okay? Okay, so by the way, you also see 2 different shapes, right? You see an oval shape in this diagram, and you see a square shape, right? A rectangular shape, right? So the square shape represents what? The class, right? And the other ones represent what? The input variables, right? Okay, so this tree, or this algorithm, decided that petal width should be at the top, meaning that the first question we're going to ask about any particular instance is about its petal width. Okay? So that's the way this algorithm decided that this is the best way to classify. Okay? So maybe it's not the best way to classify, but this algorithm decided that this is the way it's going to classify. Okay? So what it's going to ask first about the petal width. And the question that it's going to ask is it greater than 0.6, the petal width? Or is it less than or equal to? Okay? And if it's greater than 0.6, then we're going to follow the what's called the branch or the edge that goes to the right from the top, from petal width. Okay? So then, if it's greater than 0.6, then the algorithm, that we built using J48 is going to ask about what variable next? What's the next variable that it's going to ask about? Again, it's going to ask about petal width. Okay? So, what's it going to ask now? It's going to decide on, is it greater than 1.7? Or is it less than or equal? So this is just the way the algorithm thinks this is the best way to make predictions. Okay? So if it's greater than 1.7, what happens next? So we follow the branch to the right, and what? It predicts that it's going to be Iris virginica. Okay? Now there's some numbers there, and I sort of forget what they mean. I think that what they mean, no, I don't know what they mean. So I'm going to use that as an assignment for you to figure out what those mean. So you're going to have to look up information about Weka, because this is peculiar to Weka. This diagram is Weka's diagram, and just how, so whatever they wrote there is whatever they wanted to write there. So they wrote 46, right? So what does that 46 mean? And what does that 1 mean? So I want you to research that. Okay? So anyway, all right, let's go on. What if we follow this path here? So then so what does this mean? Both of the questions so far have been about petal width, right? Right? So what does this mean? If it's greater than 0.6, but less than 1.7, right? So if it's in that range, then what? Then we question its petal length, the flower's petal length. Okay, and we split on the value of 4.9, right? We say that. We split on the value of 4.9. So if it's greater than 4.9, then what do? We ask about the petal width. We're back to petal width again. Okay, so if it's, what? If it's greater than 1.5, and less than, right? So we go this way. And if it's this way, we go this way. Okay, and so on. All right? And so that's how this tree works. Okay? So that's how J48 works. And our particular J48 worked very well. How many errors did it get? Only 2 out of the 51 items. That's pretty good. Here's this tree works very well. Okay? Now, you can change the options here also. How do you change them? By clicking here. And what might be interesting to change? Reduced error pruning. Seed, sub-tree raising. So these are all things that have to do with the algorithm itself. And you can change certain factors in it. So, on prune, okay, so let's try that. Where's that? Reduce error pruning or something else? I have to scroll down here. Unpruned. So he changed, okay, so this was unpruned, was false. So it's not unpruned, so it's pruned. So I guess if we unprune it, the language of pruning means what? Cutting branches. So we're going to make it unpruned. Okay, let's try that. But how do I can't see this here. My screen is too small. I have to do this. I have to make that resolution small. Oh well, you could try it. Okay, I can't get it to work here. Okay, and probably what that's going to do is give us more branches in the tree. Okay, now it may not, just having more branches may improve the performance, or it may make the performance worse, right? We don't know. Okay? So you can test it, okay, to see. And that's the way data science works. There's no, rule about how you should do it. The goal is to get a better, so maybe if you think carefully about the data, but, sometimes you're just doing it blindly. You're just making changes without having any insight into the data. And that's a very new, I'll use that word again, paradigm in the way to do science, right? It's almost not science. In fact, that is really not science. That's not what we call science, right? Science is what? Trying to understand the underlying mechanisms. I remember I had a physics professor who used to say that science is paranoid because it thinks that there are underlying mechanisms that are, driving things. Like we understand the economy, right? We come up with these laws, these mathematical laws that we think drive, are actually the way economies work. Or in physics, we come up with these physics laws. He called it paranoid because, we're going under the surface, like dreaming about, people are attacking me, right? It's not things that you can actually see, right? You're just a paranoid person, and you think that, there are people watching me all the time, right? It's like going under the surface and imagining that there are things that are there that actually aren't there. Okay, so that's a little bit of a very perverse way of thinking about science, but but anyway, in science we do, look for underlying rules, but this is not that, right? This is just letting the data teach us, and not doing any sort of inner exploration ourselves. So it's very different, fundamentally different, and it's kind of a big controversy, about is this okay to do it this way? The thing that argues about it being okay is that it works so well. If it didn't work well, the scientists would just say, get out of here, you're just, this is garbage, what you're doing. In fact, I remember I went to see a doctor once in Fukuoka who was from Amsterdam, so he was a Western doctor, and I told him I was studying data mining at that point. It was called data mining. And that was a very bad word in the scientific community. And he said, that's garbage. What do you mean you're studying data mining? That's like exactly the opposite of what you're supposed to be doing. This was a long time ago. This was 10 years ago. He might have changed his mind now. But the concept is really, sort of anti-science, right? So you should be aware of that, right? It's really not like normal science at all, but it's so accurate that it's hard to argue with it, right? What makes science, why do we revere science? It's because it's useful, right? It works, right? Newton's laws of physics work, basically, right? So that's why we revere it. Like if it didn't really work, even though it seems like, oh, it's logical and all this stuff, we'd probably never even bother with it, right? So it's the effectiveness that makes us gravitate towards it, right? So, but anyway, it's really anti-science in a way, okay? So that's an important thing to know about this whole field. So you have to decide, what is it good or is it not good? But I think, who can argue with the fact that you can talk to your phone and, it understands you, right? I don't think people want to throw that away, right? So anyway, okay, that's all. I will give you some assignments through Manaba.